All right, today's lesson is 4.8, complex numbers, also known as imaginary numbers. All right, so we've talked about a lot with solving quadratics, and we talked about when you can't solve necessarily because you have no real solution. It's still a graph, it just does not cross the x-axis. So we can work with these things by using the imaginary unit I. So that's an I. I make it a little kind of like italicized I guess, as a font. If you thought of it that way, that's usually how it's written, and you'll see it in a book or in kind of your Math Excel. But I is the imaginary unit and what I is going to represent is the square root of -1. Because if we take the square root of -1 on our calculator, it'll say error. There's nothing I can square and get a -1, right? If I square any negative number, it becomes positive. All right, so the number, the square root of -1 does not exist. Okay, so then a lot of students are like, why do I really care? Why are we working with a number that doesn't exist? Well, if we square this number, it does exist. So if I take I and I square it, that means I am squaring my square root. So I squared is -1. And that's the big thing to understand. So squaring my imaginary number that technically doesn't exist creates a real number. All right, so then we can still work with these things. There's still applications that you can continue to do math with numbers that do not exist, because eventually it turns out to a number that does exist. A very abstract concept. We won't get into much of the applications because they're a little bit more challenging. There's definitely some things with electricity that you can work with this with, but we won't get into it. Okay, so you might be asked to just simplify using our imaginary unit I. So if I had a problem that was the square root of -100. Here on a calculator, doesn't exist, right? Truly that number doesn't exist. But we can write it in a new way using our imaginary unit I. Okay, you can kind of think about breaking it into moving your -1 separately from my square root of 100. Because my square root of -1, I could rewrite as I, and the square root of 100 is 10. So we'd write this as 10I. Okay. Or if I had something like the square root of -48. Okay, if you wanted to separately write the square root of -1 separately from your 48, you can. Some students will just go ahead right away, put the I in front, and then leave the 48 inside and just kind of jump to that step right away. That's fine. We'll still have to simplify radicals if we can. So there is a perfect square that divides 48. 48 itself is not a perfect square, like 100 was. So we're going to have some things left in the radical. So we're looking for the largest perfect square that divides 48, which would be 16. Yeah, times 3. So the square root of 16 would give me 4. So then I would write 4I times the square root of 3. And remember, I is just representing the square root of -1. So it's not a variable in the sense like I'd solve for I and figure out what I equals. We know what I equals, but now we can work with this number and do other things with this since I don't have a negative in my square root. That's kind of the point of what we're looking at. Okay. Some other things that we might have to do, there is a standard form for imaginary numbers or complex numbers. So your complex number standard form would be in the form a plus b I, where a is the real part and b is the imaginary part. All right, so you'll have some problems that will ask you to put it in that standard form. I'm not positive if MathXL is going to be that picky to if you wrote it in the form bi plus a, if it would accept that. Me, I really don't care on the order. I care that the number you have in front of I would be the correct number, and then your real part number would be the correct number. I'm not sure if it's going to be that picky to your real parts first and then your imaginary parts second. So just double check that when you're entering things in. I'm not positive. I'd have to double check if it's going to be that picky. So for example, if I have 2 minus the square root of negative 25, and I want to write this in standard form. So I write 2 minus the square root of 25 is 5, but the square root of negative 25 doesn't exist, but I can write the I in front and then put the 5 with it. So I usually don't write I5, right? Just like when you have a variable, you wouldn't write it like that. So the I is going to come after my number. So that would be my real part as 2, negative 5 is the imaginary part. And so this is in my standard form. I can't simplify it any further because I can't subtract an imaginary number from a real number. That wouldn't make sense, right? Okay. So then there's a few other things that we'll do with our complex numbers. We will add them, subtract them, multiply, and do some things with division. And so that's what we'll look at for the remaining problems in our lessons here. So we'll go ahead and perform the operations, so whatever they're telling us to do, and write our answers complex number standard form. Okay. So let's look at negative 3 plus 7i. So I have it in parentheses because that represents one complex number in its standard form. Then I'm going to subtract another complex number. So 5 minus 4i. All right, and then we'll write our answer in our final complex number standard form. All right, the parentheses are necessary for, I got to make sure I subtract each part. All right, they're not really necessary for this first complex number. All right, but I need to make sure I subtract 5, and I need to make sure I subtract a negative 4i. All right, I'm subtracting each part. If I forget to subtract the second part, that means I'm adding it, which is not what I'm doing at this time. So that's going to change this to plus since I'm subtracting a negative. From here, it's just combining like terms. You can only put real parts together and only put imaginary parts together. So negative 3 and negative 5 would make negative 8 for my combined real part. And then 7i plus 4i would be 11i for my imaginary part. And then I can't put those parts together. So that's it. Okay. Let's look at addition. So I have 5 plus the square root of negative 36. That's one complex number plus 2 minus the square root of negative 49 as my other complex number, and we want to add these together. Okay. Now with subtraction, I have to pay close attention to what I'm subtracting as my second number, because I have to make sure I distribute that subtraction. With addition, the parentheses really don't make a difference at all. It's just showing you this is representing one number plus another number. But really, we can take those parentheses away and just combine our like terms. All right, so I'm adding 5 and 2. So I will get a 7. All right, so now right here, when I have the square root of negative 36 and the square root of negative 49, I can't put those things together right now because it's not in a form where I can do so. So I must put it in that using the imaginary unit I so that I can combine those together. So the square root of negative 36 would be 6i minus, from this minus, the square root of negative 49 would be 7i. So I must put it in that form with the I so that now I can combine those as two things, or as one thing. So 6i minus 7i would be negative 1i. You put the 1 there if you want, but not necessary. So that's my final answer. So all your answers, you will leave I in the answer. You will not have any radicals with the negative. Those will all be replacing with I. Okay? All right, let's look at multiplying. So negative 2 plus 4i times 3 minus I. All right, if there is no symbol in between, that means we are multiplying. All right, I will have students who will look at problems like we first did with number 1 and number 2, and they'll see those two sets of parentheses, and they'll start distributing and multiplying everything out. Make sure you are paying attention to this is adding, this is subtracting. Just because there's parentheses doesn't mean you're always distributing everything. All right, so pay attention to that. I'll have students who will do that wrong all the time. All right, now is when I'm actually going to, do my FOIL or my double distributive property here. So I'm going to take negative 2 times 3 for negative 6. Negative 2 times a negative I would be a positive 2i. Plus 4i times 3 would be 12i. And then 4i times negative I would be a negative 4i squared. So not any more difficult than when we've distributed things before. It's really kind of like I is just a variable in a sense. So I'll combine my like terms again. So 2i plus 12i would make 14i. And then I've got that minus 4i squared. So typically we would be done, but there's one more step to go with our complex numbers. We talked about in the very beginning, I represents the square root of negative 1. But if I square both of those things, I squared is just negative 1. So that means I will never leave I squared in my answer. Because I squared equals negative 1. So I will always replace I squared with negative 1. So I've got negative 6 plus 14i minus 4. And instead of I squared, I write negative 1. So whenever I multiply it by negative 1, it's just changing that sign. So negative 6 plus 14i turns into plus 4. Okay, so now I have a real part to add to my other real part. So my negative 6 plus 4 would now make negative 2 plus 14i. Okay, because when we're done, we should always have that real part and that imaginary part. okay, as just two terms. So we'll never have something as squared in the end, because that will turn out to be a real number that I can combine with my real part. Okay, so that's really kind of the new part when we're just distributing something like that versus what we've done in the past when it's just a plain old variable. Okay. All right, we're gonna move on to division, but before we talk about division, we're gonna talk about a complex conjugate. All right, so my complex conjugate will be important for division. All right, so if A plus BI is a complex number, then A minus BI is the complex conjugate. So if you look at that, all it's saying is your numbers stay the same. So whatever number A would be, whatever number B would be is the same exact number, but I'm switching the sign in between them. And there will be a reason for that. So if I have, for example, 3 plus 5i, the conjugate would be 3 minus 5i. Okay. If I have negative 10 minus 3i, I still have negative 10, but I do plus 3i. So I'm only changing the sign in the middle. All right, I did not do anything with the sign in the front of your real number, only the sign in between the two. Okay, so we'll want to keep that in mind. We'll go ahead and head to lunch here. So the reason why conjugates are important is if we take and find out the product of a complex number and its conjugate. So if I take 4 plus 3i, for example, its conjugate would be 4 minus 3i. If you multiply that out, neat things will happen. All right. So I get 16 minus 12i plus 12i. And my last term is minus 9i squared. So my negative 12i plus 12i would cancel each other out. So that's always going to happen if we have the same exact thing in each set of parentheses, right? If you switch that sign in the middle, it's always going to cancel out. So now I'm left with 16 minus 9. But remember, you do not leave the I squared. We replace I squared with negative 1. So this turns into 16 plus 9, which is 25. So I just took two imaginary numbers, multiplied them together, and I got a real number. Isn't that neat? Technically, those numbers don't exist, and we created one that did. I think it's pretty cool. All right, so here's what we're going to do with our conjugates. We're going to use it for simplifying a division problem. So we're going to simplify our next couple of problems here. When we have division, there can be no I in the denominator. Okay, I, remember, represents the square root of -1, so if that's in the denominator, we have a radical in the denominator, which we're not allowed to have. So we talked a little bit in the review assignment from last week, how to rationalize that denominator. So here's my problem. I got 3 plus I divided by -1 minus 2I. I don't know why I put it in parentheses. I think just, it doesn't need parentheses, but I was going to put it in parentheses anyways, because what I'll have to do in order to get rid of I in my denominator, I'll have to multiply this by its conjugate, because then I'll get a real number in the bottom. So -1 stays the same, but I change the sign in between my -1 and my 2I. And if I multiply a fraction by something, I must multiply the top by the same thing. Okay? So then I'm going to distribute everything across the top, distribute everything across the bottom. So quite a few steps in this problem. So I'll just start with the top. So I've got -3 plus 6I minus I and plus 2I squared. We'll need to simplify some of those things up on top, but for right now, I'm just going to leave it that way and then multiply out the denominator. So -1 times -1 is 1. -1 times 2I would be a -2I, and then a positive 2I, right? Those should be canceling out if we set up the proper conjugate. And then I'm taking -2I times a positive 2I. So that's a negative. Make sure you multiply the 2's and make sure you remember to put that I squared. Okay. From here, I got to simplify what's on top and the bottom. So I got to combine some like terms. I'm not going to leave any of those I squareds in there. So I can combine 6I minus I. So I got -3 plus 5I on top. Then remember, I squared equals -1. So I'm going to take 2 times -1, which changes that to a -2. So then I'll be able to combine those real parts. But I'll go ahead and just simplify the denominator before I go too far here. So those will get canceled out, -2I plus 2I. Remember, -4, you're going to multiply that by -1 to replace the I squared with its value of -1. So that turns into a positive 4. So what I have is -5 plus 5I over 5. Okay, it's going to ask you for your standard complex number form. So that means I need to separate the real part and the imaginary part. And technically, this isn't simplified anyways. So to separate the real part, take your real number, divide it by your denominator. Take your imaginary part and divide it by that denominator. And in some cases, we'll have a number on the bottom that I couldn't divide out, and that would be it. We would be done. But since I can divide these, then I will. So -1 plus just I. Okay. All right, so the last thing we're going to look at is solving with our complex numbers. So we'll have some imaginary answers. So we're almost done. It's kind of a lot to take in. So if I've got 4x squared plus 100 equals 0. So we've got some methods for solving. We've got square roots, we've got factoring, we've got quadratic formula. Now I don't have an A, a B, and a C, so my suggestion is to not use the quadratic formula. If this was a subtraction right here, that'd be a difference of perfect squares and it would be factorable. All right, if I am solving any problems and they're supposed to be turning out imaginary, you're not going to be able to factor it. So that's a clue for you there. But we could do square roots with this one because all I have is the x squared as my variable. So if I just get that by itself, so subtract 100. So 4x squared equals negative 100. Divide both sides by 4. So x squared would equal negative 25. So before that might kind of ring some alarms in your head that you did something wrong, but we know a way to write this now. I can write that as 5i. But remember, there are two things that make this true. Just like when we solved x squared equals 25, we said both positive 5 and negative 5. So both positive 5i and negative 5i would be part of the solution. Okay, because if I square 5i, that's going to turn into 25i squared, which would be negative 25, which is what we want. And if I take negative 5i squared, well, squaring that negative will make it positive, and then that I squared would turn it to negative 25. So both would make sense. Okay, the last problem we'll look at for solving, and the whole lesson really, would be x squared plus 3x equals negative 7. Okay, this time I've got an x squared and I've got an x, so I cannot use square roots. But I'll go ahead and get it equal to 0 then. If I have a, b, and c, that's always my first step, is to get it equal to 0. Okay. There is nothing that multiplies to 7 and adds to 3. So I know for sure this can't be factored. So my only option is quadratic formula right now. So I'll take x equals. My b is 3, so I use the opposite of 3. Plus or minus the square root of my b squared minus 4 times my a, which is 1, times my c, which is 7, all over 2 times my a. So what's going to happen in problems in this unit is we're going to end up getting a negative in the square root, which we would say is no real solution. That's true, but we are going to write it as an imaginary solution. So 3 squared give me 9. Then I've got 9 minus 28. So then negative 3 plus or minus the square root of negative 19. Divide all that by 2. Okay, so I'm just not going to be able to simplify it any further, but I'm not going to leave the negative in that square root. So I'm going to go ahead and pull the I out, and that 19 will stay inside. And technically, I got to separate it from the real and imaginary parts. So I write it as kind of two separate fractions. Now in Math Excel, I'd be writing negative 3 halves plus I square root of 19 over 2, comma, negative 3 halves minus I square root of 19 over 2. So kind of a lot to type in, right? But that is what's happening. So same math, but now we're just getting a negative in the square root. Okay, that is it for our complex number lesson. This is the last lesson of this quarter for Algebra 2. Good luck on your homework.